Hello all, we are the students of Vishwakarma Institute of Technology Pune. Myself Akshay Khare and my group members are Rajas Rakhe, Rohan Kulkarni and Gajendra Jangir. So this is a video on our home assignment of the subject cloud computing. We have done a blog on topic cloud PubSub. So let's get started. Uh, yeah, so sometimes we have to process many requests, but we cannot handle that load because of computer's processing speed. So it's a situation in which ultimately your service will stop or requests will begin to time out. So this particular situation requires the use of technology called as a message queue. So we can use the message queue by adding the user's incoming request to the queue, and once they are in the queue, your service can take each request individually and process it as it considers appropriate. So now let's understand what is cloud PubSub. So pub means publisher and sub means subscriber. So it is a publisher subscriber model. Cloud PubSub is a fully managed real-time messaging service for event-driven systems. Using Cloud PubSub, we can send and receive messages between different applications, and it is designed to provide reliable many-to-many asynchronous messaging between applications. And a publisher application can send messages to a topic, and other applications can subscribe to that topic to receive the messages. And here we listed some core concepts in PubSub. So a topic means a concept about the publisher publishes something, publishes or sends the messages. So if the application is subscribing to the topic, then it is called as a subscriber, and it will get the messages to that topic sent by the publisher. So that's called a subscription. A message means the combination of data and optional attributes that a publisher sends to a topic and eventually delivered to the subscribers. A message attributes is a key value pair that a publisher can define for a message. Now over to Gajendra.
So further we'll move to the how the PubSub works. As you can see into the diagram, the publisher sends the messages to the Google Cloud to the PubSub where it is stored in the message store, and then it is received by the subscriber by through the subscription. And can you scroll still down? So for the best example of this working of the PubSub is the YouTube, where a publisher or a creator creates a video and sends the video onto the YouTube cloud, and it is stored on the YouTube cloud, and the the subscriber or the subscriber who subscribes his or her channel, then he or she receives the notification whenever the publisher publishes that video onto the YouTube cloud. Also, when the subscriber acknowledges the that messages or that video notification, then it can be cleared out from the subscriber backlog and not delivered again. Thus, the message itself can contain the payload and the additional parameters that specify the payload content. Further, we will move to the publisher subscriber relationship. So there are three different types of the relationship. Still, you can scroll down. That is the first one is the one to many, which is also known as the fan out. Second is the many to one, which is the fan in, and the third one is many to many. Many to many means if the subscriber X wanted to receives the messages from two different publishers or from two or more publishers, then he can can be achieved by creating two different or more than that subscriptions, or can subscribe different channels, and he can receive each video or notification whenever the publisher publishes that message. So this is called as many to many. Similarly, if two applications want to subscribe to the same message from the publisher, then it is called as the many to one. And at last, by creating two different subscription from the same topic, this is known as one to many module. Further, Rajesh will go for the Google Cloud PubSub.
So talking about the Google Cloud PubSub. So Google Cloud PubSub is one of the PubSub service which is provided by the Google. So it has the functionality of scalable, reliable, and secure communications that helps to link the different cloud-based applications together that we use and that the industry also use. So in the Google Cloud PubSub service also provides the transformation of asynchronous information both inside and outside the Google Cloud platforms. So the system is now currently flexible and it is adaptable over all the circumstances. So this service has a simple interface and it is hence it is very able to utilize the HTTP and JSON through its APIs, and all these libraries are also provided by the Google. So talking about the features, Google Cloud PubSub is able to perform the global message routings to make the multi-regional system more simpler and eco-friendly and user-friendly. So in this, for publisher and subscriber, we only set the some distinct specific codes and billings. So and in Cloud PubSub, we don't allow the employees to shards or partition. Just we set the codes and we start posting and starts consuming the that PubSub service. So, talking mainly about the types of PubSub services. So, there are mainly two types of PubSub services are available. So, one is PubSub service and another one is PubSub fleet service. So, the PubSub service, which is by default option, it is used by most of the users and applications by default. So, along with this, this service ensures that all the data is replicated synchronously at least two zones, and the third zone will receive the best effort replications in this service. As compared to the first service, the second service, that is lead service, it is different but comparable message service which is created at the very lesser cost. So uh, compared to the first service, it provides less reliability also. So for this service, the topics for the zonal light are only saved in the one zone, and while utilizing this lead service, we also need to pre-provision and control the storage and throughput capacities also. So only to apply this PubSub fleet when we have to attain the low cost warrant some more operational works and to decrease the reliability of the process. So we use this service. So now I will hand over to Rohan.
Okay, so now as we have become familiar to Cloud PubSub, let's see some of its common use cases. So first would be that of a real-time event distribution. So events which are either raw or processed can be made available to multiple applications across our team and organization for real-time processing. PubSub supports an enterprise event bus and event-driven application design patterns. PubSub even lets us integrate with many Google systems that export events to PubSub. The next one would be of ingestion user interaction and server events. To use user interaction events from end users apps or server events from our system, we might forward them to PubSub. We can then use a stream processing tool such as a data flow which delivers the events to databases. And examples of such databases include BigQuery, Cloud Bigtable, and Cloud Storage. Then next would be the parallel processing and workflows. So PubSub can be used to efficiently distribute a large number of tasks. If we are creating a website similar to YouTube, we might give away many different jobs when a user uploads a new video. For example, we could have one process for re-encoding the video to different resolutions, another could be used to scan for copyright infringement, and a third process might be used for generating closed captions. So all of these tasks and more can happen in parallel using auto-scaling microservices. So in short, we can efficiently distribute many tasks among multiple workers by using PubSub messages to connect to cloud functions. The next one is the enterprise event bus. So we can use Cloud PubSub to create a real-time enterprise-wide data sharing bus, and business events, user interactions, and system failures all can be tracked and responded to as they occur. Next is data replication among databases. So PubSub is also commonly used to communicate database change events. Any interested service can get a notification for when a record is added, edited, or deleted. Now these events can be used to sync multiple databases or create incremental backups or to log all changes for later big data analysis. So these events can be used to construct a view of the database state and state history in BigQuery and other database storage systems. Next is the load balancing for reliability. So for example, instances of a service may be deployed on compute engine in multiple zones but subscribe to a common topic. So when the service fails in any zone, the others can pick up the load automatically. An example for this case may be that if we have an application publishing from regions A, B, and C, and regions A and B go down, the application in region C is unaffected. At the same time, traffic from applications in A and B is load balanced out to C or any other region. The next one would be data streaming from application services or IoT devices. So IoT devices are constantly generating lots of data. We can use PubSub to capture, store, and filter this data so that our services are not overwhelmed with lots of unnecessary notifications. The last would be that of a refreshing distributed caches. So caches are an important tool for improving system performance by having the latest message available to the subscribers stored locally nearby and updating this copy only when changes occur. So depending on our applications, we may need to distribute them across multiple systems. But with PubSub, we can seed caches asynchronously. And as processes create data and events, the messaging system delivers events to caches. As such, rather than waiting for a nearby client to make a related request, the data is already in the cache. I'll hand over to Akshay.
Yes, so now let's talk about advantages of PubSub. So first one is simplify communication. The development and integration of communications code might be challenging. The publish subscribe paradigm reduces the complexity by switching out all point-to-point connection for a single connection to a messaging topic, which will handle subscribers to decide which messages should be sent to which endpoint. So less callbacks results in less coupling and easier software modification and maintenance. Second one is eliminate polling. So PubSub messaging is extremely useful for programmers who build a real-time event-driven application, and the immediate push-based transmission made possible by message topics eliminates the need for message recipients for frequently check or poll for new information and update. So this promotes a quicker response time and reduces the delivery latency, which can be problematic in systems where delays are intolerable. Next advantage is decouple and scale independently. So through PubSub, software is made more adaptable, and because of publishers and subscribers are not tied to one another and run independently, so we may expand and scale them separately. So if we choose to handle request in one way this month and in another the following month, so the system won't be affected by adding or removing the functionality because of PubSub, because the PubSub allows us to be flexible in how everything interacts with everything else. Next advantage is dynamic targeting. So PubSub makes service discovery easier, more logical, and less error prone. So instead of maintaining a list of peers to which a program might send messages, a publisher will just deliver messages to a subject. So by adding their destination to the subject, and interested participant can thereafter start receiving these messages. So the system adapts on the fly when customers change, update, grow, or even vanish. Yeah, over to Rohan.
So now let's see some disadvantages of PubSub pattern. So although PubSub is a robust communication service, it is not always the best option. So let's take a brief look at some of the limitations of this method. The first one would be that it is critical to appropriately manage and implement PubSub. And implementing PubSub in cases where scalability and decoupled nature are not required, components of our program would waste resources and add unnecessary complexity to smaller systems. Secondly, when working with media assets such as music or video, PubSub is ineffective since these files require flawless synchronized streaming between the host and the receiver. So, because it does not provide synchronous end-to-end communications, PubSub messaging is not suitable for the following. Next disadvantage would be that testing may be challenging because interactions are not synchronous. Testing does not need sending a request and then analyzing the result. To identify when and how the message is handled, a message must be placed into the system, and the test must then be observed the behavior of the process under test. So furthermore, if the test method requires absorbing a significant quantity of messages from a certain subject over time, the testing regimens may become increasingly difficult to manage. Next would be because the intermediary may not tell the system of the message delivery status. There is no way to determine whether a delivery was successful or failed. So tighter coupling is necessary to achieve this. Next disadvantage would be of malevolent publishers can infiltrate and attack the system. So that may result in the publication of unwanted messages and the availability of communications that subscribers should normally get. And lastly, message formatting and exchange necessities a well-defined policy. Otherwise, message consumption may become distorted and more error prone. Now over to Rajesh.
Okay, so let's see about the comparison between the two famous messaging services, PubSub and Apache Kafka. So PubSub, it is one of the messaging service, so which helps for the sending the asynchronous messages, where messages can be distributed asynchronously through several application sections. So on the other hand, there is a Apache Kafka, which is one of the distributed and open source platform which enables the applications to publish, subscribe, and store the process event streaming. So mainly the PubSub message is a queue while Kafka is an event streaming platform. In the above diagram, you can see that where each M in the diagram, it stands for a message. The Kafka has the Kafka brokers, which maintain the horizontal rows of partitions of the messages. So here customers access the messages from a specific partition. While on the other hand, in case of PubSub, there are no such divisions are present. Instead, the readers read from the topics that automatically scales into the respond to the demand. So to in order to manage in Kafka configurations to manage the traffic, overall consumer traffic, Kafka has provided the horizontal rows of partitions, while in case of PubSub, all it is done automatically based on its demand. So now further, Gajendra will explain.
Okay, thanks Rajesh. So further we'll move to some more comparisons, that is the if you'll compare between the on the basis of availability, then the Kafka is manually deployed to the additional location, whereas in the comparisons of the PubSub it is deployed by the Google Cloud for the high availability and the low latency. Secondly, if we'll talk about the capacity and the destructive recovery, then the uh, PubSub is deployed by the Google, but if we talk about the Kafka, then it need to plan manually the storage and compute need in the advance, whereas also it need to maintain its own backup and the decryption. Thirdly, the Google manages the infrastructure of the PubSub, whereas the uh, Kafka manually need to deploy this and operates the VM and its machine. Fourthly, the consistent variation and the patches must be maintained by us. The also the PubSub provides the 24 4 hour on the call staff and the support, whereas the Kafka don't support this and don't deliver us. And the messages on the PubSub can be stored for 24 hours 7 days, but Kafka doesn't do such things, as there is the limitation available in the machine storage. And so the Kafka logging and the monitoring is the self managed, whereas the PubSub is automated with the cloud logging and the cloud monitoring. Further, we move to the conclusion. So from this blog we conclude that the PubSub pattern is on the is based on the asynchronous architecture design, that is the based on the Google Cloud, which means we don't need to manually do such things. Secondly, the PubSub pattern focuses on the numerous communication programs and the cloud services. Yes, there are some challenging faced in the to use the PubSub, that is like the server themes are at the play. But if the fundamentals of understanding this PubSub is very simple, and by putting this into the practical, it can be difficult based on the messaging system being used at the volume of the asynchronization action that need to be supported. So however, the PubSub paradigm is quite common when it is comes to handling the asynchronous communications between the component and the service in the big distributed applications.
Yeah, so the link to this blog is available in the description of this video. Thank you.